Yes, so I'm a senior solutions engineer with Kinetica. Very excited to present this bee health extreme ecology advanced analytics solution to you today. And I'm also, this project is ongoing. So I welcome dialogue about what we're about to show you and ideas around, how we can take this to the next level. It is ongoing. We are actively working on this to build this out. So this has been a very interesting and fun experience for me, personally as a father and professionally as a data enthusiast. When I see this butterfly named Jade Greenberg, my daughter, who is a junior in high school, flaps her wings and causes this hurricane across all of our partners, technology partners, and my peers at Kinetica and NVIDIA and Microsoft. This is a story about what happens when a high school student with an idea has the power to influence so many so quickly, bringing together all these people, technologies, and disciplines with the potential to change the world for the better. It's an inspiring story. If you're not familiar with the story behind this bee health solution, I encourage you to check out the blog. It's posted on our Kinetica website. It has Jade's story on there, and if you stop by the booth, I can show you. There's even a video of Jade explaining the science behind her beehive theories that inspired this advanced monitoring and analytics solution that we're going to share with you today during the presentation. So now let's talk about why the honeybees are in trouble and what Kinetica, NVIDIA, and Microsoft can do about it. So during the winter of 2006 to 2007, some beekeepers began to report unusually high losses of anywhere from 30% to 90% of their hives, where as much as 50% of those that collapsed demonstrated symptoms inconsistent with any known cause of honeybee death. So without a clear consensus of the cause, they dubbed the phenomenon generally as colony collapse disorder. But over time, researchers started to focus on these specific factors having to do with poor nutrition, pathogens, pesticides, and parasites, where in many respects, the various combinations of these factors were considered to be the key contributing stressors to beehive health. So research is ongoing to this day. There is no conclusive remedy to the problem, and the collapse rates over winter and summer continue to be higher than what is sustainable. And the rates of these hive losses amounts to a significant cost for the commercial beekeeper, as well as to the farming operations they support. So Jade's theories have to do with the current and most popular domestic honeybee hive design called the Langstroth hive. This is a file cabinet shape and operation. It's good for honey production, but it actually, in theory, weakens the health of the entire organism and is completely different in shape and structure to what the honeybees build for themselves in the wild. So if Jade were to introduce a new hive design in the field, what are ways to monitor and analyze its effectiveness? And how can we capture whether the bees themselves are healthy or at risk to parasites and or disease? So she's going to go through cycles of her hive iteration, and over time, the various possible sources of data that we can collect and the analytic insights they can provide become critical to accelerating the engineering, identifying signals to whether the beehive is in fact an important vector to overall bee health and a more natural defense against these hive collapsing stressors. So herein lies the extreme analytics challenge. So is it possible to deploy sensors and video capture at the edge to study the effectiveness of modern hive designs and bee health over time to enable real-time iterative data exploration, experimentation, visualization, and gather insights? So now with the collaboration of our partners between Kinetica, NVIDIA, and Microsoft, we have the ingredients necessary to meet this extreme ecology analytics challenge. And it starts with the massively parallel processing of a GPU, NVIDIA GPUs for compute, along with some Python scripts, some TensorFlow neural networks, and we also employed the Microsoft Cognitive Toolkit. And from here, we can build various machine learning approaches to training models for image inferencing, from image capture, and also running models from edge devices with live video feeds. So with Kinetica, we can capture all of this edge compute and live sensor data from any number of devices, streaming data in real time, while simultaneously running analytics, models, and visualizations with BI tools such as Tableau, all running from this advanced GPU-enhanced platform. And this entire solution can be operationalized on an NVIDIA DGX station. So we have all the ingredients for this layer cake of insights, if you will. So now let's talk about and take a closer look at some of the machine learning approaches. And we can use that we use to train models to visually identify from image capture and live video healthy versus unhealthy bees. So we used a transfer learning approach, leveraging the Inception v3 pre-trained CNN model using TensorFlow, which this provides image feature extraction layers and classification layers right out of the box. So this allowed for the bee learning model to leverage very high accuracy for recognizing objects across thousands of classes. You know, what is a cat versus a zebra versus a car, right? And so on. So the model extracts these general features from the input images and then classifies them into vectors with over 500 dimensions. And this is also using over 20 million parameters. So then when we add our bee training set, we reduce those down to 2 dimensions, recognizing whether the bee image has a parasite on the bee or not. So is the bee healthy or unhealthy? And then we store those results back to Kinetica. So that gives you just a high level of the model and models that we employed. So now we also leverage some mainstream edge devices from vendors such as Eyes on Hives and Beware Smart Hive Monitor. These were providing sensors that were capturing hive weight, humidity, temperature, and even running algorithms on live video to determine bee activity, swarming events and things of that nature. And this is all happening at the edge. And we also tested an NVIDIA Jetson TX2 running a bee parasite detection model on live streaming video at the edge. So now we have the data sources from various sensors. We have computer vision working together across several dimensions to capture high performance and bee health in the field. And then we realize the analytics results to the Kinetica platform for further analysis by beekeepers and data scientists. So we're starting to get a sense for some of the technologies, the disciplines that we employed, and the types of data sources that we can start to leverage. But just to give you a sense of the potential scale of this monitoring bee health challenge, how much data are we talking about in the US alone? So if we attempted to capture just 10% of all hives reporting bee health, it would amount to about over 144,000 hives would be transmitting data. This would amount to potentially 208 million rows per day, which translates into about 6 billion rows per month or 77 trillion rows per year. So that's a lot of honey. But from our perspective, this isn't just about data volumes, the variety, the velocity, the veracity, all that good stuff. But it's coupled with all of the dimensions of the solution engineering across various technical domains, leveraging big data, and the powerful impact of being able to now operationalize the BI and the AI insights together at scale from a single platform, accelerating outcomes. So as a whole, this represents what we consider to be an extreme data paradigm. And we're seeing these extreme data opportunities across many industries. Whether it's financial services, telecom, logistics, retail, automotive, energy, oil and gas. The scope of the competitive advantage in each one of these verticals may be unique. However, the same extreme data solution engineering principles still apply. Whether it's streaming sensor data and capturing it, running machine learning neural networks on top of it, or applying complex analytics to the data sets, running geospatial, and getting interactive visualizations all at the same time at scale. And this is what represents what we consider the extreme data economy. So I really chuckle when I see this slide. So how many know what that game is? And we're all dating ourselves. So that's Atari Pong. So we're basically asserting that by today's standards, 64 CPU cores is now equivalent to running Atari Pong versus the 5,000 plus cores of a GPU. And fundamentally, the amount of parallel processing threads is an order of magnitude beyond what a CPU can do what a GPU can do beyond a CPU, by what a CPU by itself is capable of doing. But in truth, CPUs are absolutely necessary for the computer operations, but by combining the massively parallel processing of GPU cores, compute performance can be scaled to unparalleled speeds. So Kinetica is designed from the ground up to take advantage of this brute force compute enhancement. And with the introduction of the NVIDIA DGX station, the GPU scale is just crushing CPU-bound compute architecture. So now, here we can see all these features coming together. B scientists and data scientists working together for one comprehensive platform to help solve a real-world problem. And now they can run their business intelligence and query tools while also potentially integrating any custom application requirements and also leveraging geospatial and mapping visualizations and possibly incorporating operational and interactive machine learning processes and streaming data from the edge compute devices and sensors. So, and all of this is accelerating insights by the massively parallel compute processing power of the GPU. So all of these core features enable Kinetica to fit within various technology landscapes, and in many ways leverage technologies that you already have, providing this modern GPU compute layer that serves the needs of analysts, data scientists, and application developers. So again, we're almost through the slides, and I'll do a couple demos, show you a couple demos. But let's call out a couple key factors for the solution engineering and that supports the extremeness of this use case. So if you're going to be streaming all these updates from all of these hives across the country, thousands of sensor devices, tens of thousands, handling data, the data ingest is paramount. So Kinetica does a multi-thread, multi-head ingest, which supports basically a parallel load across these real-time data sources, and it takes advantage of the distributed architecture, and it's as effectively storing data as fast as it's coming in. So this makes Kinetica ideal for this massive streaming data sets. Also, Kinetica can scale linearly, so if you start small and you want to scale up over time, you can as you add more and more hives in this particular use case. So now with business intelligence, our BEI tool, pardon the parlance, I heard a couple chuckles, so you're with me. We can demonstrate fast live query. We can, on extreme data at scale, without having to pre-aggregate this raw base data coming in, we're connecting through ODBC, JDBC, and by simply supporting SQL, Kinetica fits with existing analytic technologies and skill sets. Potentially, you can use the tools and logic that you already know. And lastly, with our streamlined machine learning capability, models can be deployed and operationalized and integrated with the BI analytics. So all of this comes together. All of these, what we would consider extreme data dimensions, come together on a single GPU-enhanced data platform running from an NVIDIA DGX station. So now let's just take a look at some of these demos real quick. So this is a video capture of an example of the portability of a model, being able to compile this model so that it can be run from a cell phone. So here is just an example of a visual inferencing model running from a cell phone that can just take its video and then analyze, and it'll light up when a mite is detected, and it will not light up if a mite isn't detected. And in this particular scenario of edge compute, this data could be collected on the cell phone and then streamed back to Kinetica for analysis. So this is one example of edge compute. So here is another, jump too fast. So this is the second example of edge compute that we employed. So this is a video of the Jetson TX2. And it's basically, there's a video feed coming into the TX2, and then you're seeing this incremental counter on the upper left-hand corner of the screen. And what's happening is as each time the algorithm passes over the video, it's trying to identify, is there a mite or not? So every capture is data that you can write back to Kinetica, and then you can calculate from there, am I detecting on average more mites? Can I look at this over time? Can I put other factors into a model and then figure out the propensity of things that have happened that may have created this parasitic event, the way that created the conditions that made it, more accessible for the mite to infest the hive, things like that. But it's kind of cool. This is running on the edge, the intelligence is running on the edge, and then the result set just needs to be sent back and can be streamed technically to Kinetica to be incorporated in further analytics. So let's do a little demo with our BI tool. So I'm going to go ahead and launch a VM because it's Tableau. It likes Windows, although we do have it running on Mac and Linux. Let's try it this way. Just going to pop this out real quick. Are we back? Survey says. Did it somehow create? Oh, lovely. That's going to make this fun. Let's see if we can't gather this. Apologies. How about now? Better? Okay, sorry about that, folks. Decided to just do a hiccup on me. Okay, so back to our demo. So now I'm going to open up Tableau. Right, so we're going to launch a dashboard, and we're going to highlight how we can effectively leverage all of the sensor and video image capture data that we're using from these sources. The analytics, the machine learning, the geospatial, visualization, with the Kinetica Insight engine and the DGX on the back end, and Tableau Desktop serving as our front end. And this is for real-time interactive and visual data exploration. So this is going to demonstrate what a bee scientist can do at the end of all this when it's operationalized at scale. So if I just quickly walk through the functional components of this example, provided my mouse will cooperate, right? I think it's important to just switch over to the data source so that you can see we're running this entire demo live. So are there any Tableau developers out there that understand Tableau? So it's just a BI, it's like any other BI tool, but Tableau does a really good job of having a dashboard that you can interact with that sends a live query back to the database. So instead of having to extract your data and store it locally in the tool, you can actually just connect up to Kinetica and you can run these queries live. And the really powerful aspect of that is that you don't have to pre-aggregate, you don't have to run through this extract process, you don't have to store these extracts local, you eliminate all of that, and now a tool like Tableau with Kinetica behind it could be querying billions of rows in sub-second, tens of billions of rows in sub-second. So that's important. The other important factor of this is you'll notice I didn't really have to model my data here. So you can, in Tableau, drag in a bunch of tables, create a bunch of join criteria, maybe it's a star schema, snowflake, whatever you've got, and you would model it here, and then Tableau would generate the SQL behind the scenes. So it's designed to make it easier for you to interact with your data, however your data model is architected. Well, in my case, on Kinetica, I can actually run what's called a projection, which allows me to create a very simple denormalized and billion-row table, couple billion-row table, and then I can add additional logic and put attributes in there that I would normally have to derive in my tools. This puts more of the work down into the Kinetica database where we can crunch this kind of stuff, makes it easier for you to manage your BI tools and work with these visualizations, and I like it because it just streamlines the whole dashboard creation process, any enhancements I have to do. It just makes it really easy to work with. So just know that you can do this in Kinetica. It's almost like a self-service data provisioning tool. And we generate these things super fast in seconds on top of billions of rows. So now going back to the dashboard. So you'll notice we've got like, I'm just going to zoom in on this, doing presentation mode, here we go. So you'll notice we've got 3 visualizations on here. One's a geospatial, a bar chart, stack bar chart, a line chart, about 4 filters, and then we have this indicator up here. So this indicator is actually being driven by the machine learning model that we're running to evaluate the bee images. And this is like a very simple way to just illustrate how you can start to integrate the AI and the BI in one place. Now, this entire dashboard is completely interactive. I could click this particular part of a stack bar, and you'll notice that the line chart filtered as I click that. Hopefully you saw that. So this stack bar represents the number of days that were sunny in the season of winter for 2017. And we're comparing these different colored bars in the stack to year over year, right? So we can get a sense for like, what was the weather like for certain times of the year? And is that a factor for the hive health? And then this chart down here, if I click out of this chart down here represents, sort of a trend line of like what happened temperature-wise. What was the variant in temperature? What was the variant in humidity? And I can overlay those and look at those and see if those are signals for impacting bee health in some way, right? And then from here, conversely, I could click, an element in this chart. I'm clicking the month of February. I can now filter that other chart by that particular month window, and I can click and it's very easy, and you'll notice it's coming back very fast, right? So then from here, I can also click and drag and select just a random subset of data points. Let me fix that here. You can also very easily back out anything you didn't want to have happen. So now I'm going to just randomly select a series of data points. And you'll notice that it filtered in kind and it was very fast. So the whole reason I'm doing this is these are features that are of Tableau. Interactive dashboards and visualizations that you can explore, right? The whole idea is to enable a visual exploration of the data so that as you're thinking of questions and as you're exploring, you can iteratively go from place to place. The idea of having a GPU-enhanced database powering this is super important to that free flow thought process as you explore. If I click this and I wait 5 minutes for it to refresh, it completely interrupts the creative flow of an analyst who's trying to find an answer into something, right? So it almost like will kill the whole exploratory process. So it's critical that if you're going to do this, you need a database underneath that can process these things super fast, because this is happening live. As each click, it's changing the parameters, it's changing the SQL, it's sending it back to the database and asking it to serve back the data, and this tool visualizes the result. So if I click into here, I have a link in here that can take us to the SQL that's actually happening behind the scenes, and it allows me to also showcase Kinetica a little bit on the web, where we've incorporated a SQL exploratory tool. So if you're comfortable with SQL, everybody who knows SQL, you like SQL? So from here, if you don't like the BI tools and all of the overhead there, you can just craft your SQL right here, iterate, off you go. It's intended to be a very simple tool, but to allow you to run from the web and just, off you go and get super fast results. So you'll notice in this query, this is a Tableau generated query, but I'm showing it because there's a lot of things happening in it, right? In the select, there's different levels of aggregation, there's a case statement, there's group bys, there's subselects, there's cross joins. So I'd give you a little flavor for all of the SQL support that's happening on the Kinetica side. Again, this is a new, modern GPU-enhanced database that looks like a relational database to these tools. So if you wanted to look up dbeaver or DB Visualizer, you could run your SQL there too, and it works exactly the same way. We just incorporate this to make things easy. And then if I run this, right, so this is what Tableau is sending, and this is what Kinetica is returning, and that sub-second execution time is really what this is all about. That's what makes the requests coming from these tools and the responses that get sent back super fast, right? And we're also aggregating across massive amounts of data, so what gets sent back is relatively small. So if we can really hammer the compute, and we're only sending back a small amount of data, that's how we're accelerating the experience for the user on these visualization tools. So now if I go back to our dashboard, and let me just click out of here. Let's just remove this filter. We'll bring in the rest of the data points just for interest, right? So you can see this is 4 years of data coming in across the hives. If I zoom into this map ecology piece, this is kind of cool because Here we're showcasing kind of the integration of a Mapbox satellite image, and then Kinetica is powering the lat longs to overlay the data points on top of the map. And what also Kinetica is powering is there's a feature in here, so if I just zoom in real quick, it's nice to be able to visually see geospatially where my hives are, which hive is which, and then if I want to hover over a hive to get an instant statistic, that's also important too. Now, these stats are aggregated on the fly. So imagine me creating metrics that are important to me that I need to run across a very large data set, some kind of average, some kind of min, max, deviation, whatever it is. And I need to be able to, the user needs to be able to click on that and be able to, the analyst, and have it come right up, right? So that, again, the power of the database underneath enables you to do these kinds of things and makes it iterative and accessible and usable. Super important. But the sensor data alone is not necessarily the most interesting part, right? What about that visual, image inferencing, live video, machine learning model that we were running? If I go back to the B dashboard, right, so this is a very simple indicator that's doing calculation based on the results of the machine learning model that we're running. And if I click in here and go to Kinetica. So this is instead of it doing on the edge, here's an example of where Kinetica is storing the B images that are captured in the field. How am I doing on time?
You've got 7 minutes.
Perfect. I got 7 minutes. So I might stop for questions if you want to ask questions. So this is a healthy B, right? We're storing the images in Kinetica to make it easy when we run the model to evaluate those images and then write the results back to Kinetica. So this is an unhealthy bee. You can see there's a little parasite here. They look like ticks almost. Very horrible to see what they do to a hive. So imagine the devices taking certain snapshots of the hive and then streaming that back up, and we're storing it here in Kinetica. And then from here, I'm going to click on this UDF tab. UDF means user-defined function. And here we've already published this B-infer model, the model I described earlier to you with the TensorFlow that did the convolutional neural network, and it had a pre-trained Inception v3. All that stuff is this, right? So we deployed it here. And then from here, I can quickly just execute to show an example of it. And I'll just pick the table that the images are coming from. Just do this then. Right? No, that's not what we wanted. Right, so here's the image table, and then to output, I want it to go to this B image predict table. And you can automate all of this. So I'm going to go ahead and execute that. So behind the scenes now, this model is now running. You can see there were other monitoring events that had taken place that had already completed. So it's this ongoing capture and evaluation of images to figure out bee health as an additional element to our hive monitoring solution. And what just happened was when I called that model, when I published that model to Kinetica, there's 3 ways in which we accelerate and help with machine learning on our platform. So there's this overall streamlined concept of you deployed it, we can manage it, you can deploy all your models there, and you can call up whichever ones you want. So it becomes this repository of the models that your users can execute, making it accessible from one central place, along with where the data is stored, right? That's kind of important, moving stuff back and forth. You get this benefit. Then when you operationalize it, when you execute, there's 3 acceleration things that happen. One is the model needs to pump data in and push data out. So our database is the core feature, right? So those queries are going to be super fast and GPU accelerated, and then the egress writes right back to the Kinetica database. Both those operations are going to be accelerated. Then the distribution of the model, what happens is when we run it distributed, thank you, the model is then deployed and run and executed on each individual node. So you're getting a copy of that model running in parallel, taking chunks of each part of the workload. So you're parallelizing the workload of the model in a distributed way. And then the third way is if you've somehow enabled your model to leverage the power of GPUs through, maybe the TensorFlow can do a multi-threaded CUDA core queries, if it's programmed that way, then you're also gaining the benefit of the GPUs that exist on the infrastructure, on this GPU-enhanced cluster, if you will, where Kinetica's running. And you want to run TensorFlow and also run that directly on the GPU. So all those 3 things come together, and that's how we're helping to accelerate the machine learning aspect, doing this all in one place. So this is probably done. Yep, so it's done. So we're going to go back and we're going to just refresh the dashboard. So imagine I came in, or I have it refreshing on some regular basis. And then give it a second to refresh so it's running behind the scenes. You're going to see it change red. Not very exciting. But what happened was the model evaluated the images, found a bunch of mites on the bees. We had our metric recalculate on the fly, and now the beekeeper's notified that there's a problem. As we extend this further, if we were to light up the specific hive it's coming from, and we had a link to be able to look at the video feed, we could do that. So now it's just important to call out the convergence of these types of operations and how we're now able to run these things and deliver this kind of experience from these tools. The machine learning, the AI, the geospatial, the complex query execution, the visualization, all of that coming together on one platform. So with that, I'm going to quickly jump to our last slide where I just want to call attention to all of the people that participated in this. You know, sometimes it takes a village. Oh, look at that. Why did it do that? Okay. Interesting. There we go. So a lot of people worked on this. And again, just to reiterate the fact that, it's amazing that an idea, a simple science project can bring all of these people together. And, it might just be your high school student who has an idea and can change the world. So really appreciate your time. Please come visit us at the Kinetica booth. I can show you the blogs. We can talk more about what you thought about the solution. I appreciate your ideas. And if there are any questions and we have a few more minutes, please go ahead and fire away. Oh, thank you. Appreciate it. No questions? Yes, sir.
Have any insights been made with your daughter's design yet, or over a traditional hive?
So that's a great question. So the question was, have any insights been garnered from this exercise with her hive design? And what's interesting is the design itself, the principles of the design are not new. It's called the Sun Hive, and it was fostered by a German scientist who actually wrote a complete book about and actually handcrafted the hive, because it's hard to build that kind of a structure, and studied it and came up with these theories and then actually did the field testing and saw some of the advantages, but it wasn't conclusive. It was more of like, he wrote this book, he had some nice ideas, he saw some effects. So what my daughter worked on mostly was she created a complete digital design of the hive, and then she enhanced it so that we could incorporate sensors and that we could produce it through 3D printing. So she worked on all of that, and we had just enough time to get that ready for her science competition, which she won first place in engineering in the regional science fair, and she's competing this May in the Intel International. I don't know if you know ICEF. So that's like the Olympics of like the science competitions. So we never actually got the time to take the hive and bring it to the field. The other challenge we found was these 3D printing at scale. So we printed it in like a residential size printer and got about this big. To get it to commercial size is very expensive. So we actually, I don't know if you did about 3D printing, but we found a printer in California and they quoted us some crazy number, and we actually have a GoFundMe. We're trying to raise the money to print it and test it. And now we have a bunch of beekeepers in California ready to test and put bees in it. We have beekeepers in New Jersey ready to test. So we have everything teed up. The only thing we need is the time and the funding to, not that I'm asking for funding, but like that's where we're at with it. So it's still ongoing. But she sort of like got all of the hard work out of the way. So we're just on the cusp of actually putting it in the field and testing it. Any other questions? Yes, sir.
What's the name of the GoFundMe?
Well, if you go to GoFundMe and you go to Jade Greenberg, you'll see her. And by all means, please visit her page. So thank you very much. I appreciate it. Again, happy to talk to you. Come by the Kinetica booth.